And now let's talk about a 6 billion kilometer voyage. Not by a human, of course, that would be crazy, but by NASA's saucer-shaped capsule. It was in the space for 7 years. On Sunday, it parachuted back to Earth and successfully landed in a desert in the US state of Utah. It holds precious cargo, about 5 billion years old chunks of space rock, the largest soil sample ever scooped up from the surface of an asteroid. But that's not what makes it so special. This sample comes from one of the most dangerous rocks in space, and it could tell us a whole lot about the birth of our solar system. Here's a report.
Phenomenal view of that streaking SRC coming in across the sky.
Yesterday, the arid landscape of Utah desert was brimming with drama, with scenes that looked straight out of a sci-fi movie. All thanks to NASA's saucer-shaped capsule, OSIRIS-REx. As you can tell, it's a futuristic-looking picture of stillness. But all around it, scientists were swinging into action. After a 7-year-long and 6 billion kilometer voyage, OSIRIS-REx finally parachuted to Earth, carrying precious cargo, chunks of space rock that are 4.6 billion years old. As soon as it landed, it was a race against time. Scientists and military personnel dashed to the capsule to recover it as quickly as possible. Why is that? So the samples aren't contaminated, and to make sure that everything is under control, because these chunks belong to the most dangerous known rock in the solar system, asteroid Bennu. Now, what is an asteroid?
So asteroids are the leftover remnants from solar system formation. So they're a pristine example of planetary building blocks, and studying them helps us to understand how the Earth and all of the planets in our solar system were formed.
And that's exactly what the scientists are planning to do. This is the largest soil sample ever collected from an asteroid's surface. And it has an even bigger responsibility. We told you how this space rock is 4.6 billion years old. Do you know how old the solar system is? 4.6 billion years exactly. Which means Bennu's rocks could provide crucial insights. They could give us fresh insights on how the solar system was formed and how life started on Earth. On top of this, there is a good chance Bennu will hit our planet in the next 300 years. And scientists want to stay ahead of the curve. So what's next for them?
We currently have a team of spacecraft engineers, scientists, and curatorial personnel working right now in a temporary clean room here at Dugway to make the sample capsule ready for transport down to the Johnson Space Center so that we can open it up and reveal this treasure.
Tomorrow, smaller specimens of the samples will be parceled to some 200 scientists in 60 laboratories around the world. Scientists will begin with studying the composition. Once that is covered, they will sneak a peek into answers for the bigger questions.
But we think we've got a lot of sample in that science canister, and we can't wait to crack into it. For me, the real science is just beginning. The key objective for me, and one of the driving objectives of this program, is to try to understand, did carbon-rich asteroids like Bennu deliver the compounds that may have led to the origin of life on our planet?
No matter the answer, this mission is already a success. These are NASA's first asteroid samples fetched from deep space. And by the looks of it, scientists can't wait to dig deeper into them.